Good morning, student. Hearty welcome to class 8. Congratulations to each one of you for getting promotion from class 7 to class 8. You all aware of the crisis the whole world is facing due to COVID. Due to what you last year you could not come to school. I know that you children are longing a lot to come to school, to meet your friends, to meet your teacher, and to go for this your that thrilling life as a student. What you expect, I understand that it is very difficult for you to confine yourself inside the home, but what to do now? Once again, the COVID situation is very alarming. Therefore there is no option other than online. See, I will tell you one thing. What we have experienced last year is, this online education is also, it's a parallel system of education. I will tell you, other than schooling also, if a student stays at home or want to know something from the teacher, that this is the methodology you can follow and learn it. Actually, in advanced country, on all of this online education takes an important role. They are following this procedure. So India also gradually it has come up. No problem. Of course, it is always better to have our normal Gurukul procedure, that is classroom teaching. Always it is better. But what to do? As per the situation, you have to act. So this year also we will go on with the online education till this pandemic situation become little normalized. We have to go through it. Okay, we will begin this academy. I will be teaching you maths and I will be teaching you MSc. I am fortunate enough to have you once again. As I didn't get last year, I had some dependence because I love my students so much. Okay, we will begin with maths set theory. First lesson is called idea of set. This particular lesson I have taught you in class 6. You have got some last year also. You have learned by Jail sir that what is called set. Set theory was invented by George Cantor. George Cantor, a German mathematician. He said a particular collection in mathematics can be called a set. And what is that particular collection is about? See, he said a collection whose every object should be the member of that collection. That means every object should be well defined, universally agreed that every object is distinct and well defined. I will give an example that will be better for you. I have said to you previous classes also, if you take beautiful flowers from a garden, this may not be universally agreed, it cannot be well defined. If I say that pick the red color flowers from the garden, collection of red color flower of the garden, that will be a set because red will be agreed by everybody. But beautiful is a relative term, see, to me it means roses may be beautiful. To someone, jasmine may be beautiful. Marigold may be beautiful. This is a relative term. So what you need to do, George Cantor said a well-defined distinct object collection is called a set. I hope you have understood. That is the definition of set. We will move on to some of the important aspects of this lesson. Firstly, element or member. This is very, very important. Other day, remember I asked you one question. What symbol do you use to symbolize, represent element or member of a set? Obviously, actually you know the answer, but the question was not very straight enough. It was little twisted question like, so this is belongs to. You have learned very nicely. 2 successive you have learned it. This is belongs to sign. It means belongs to means each member will be the part of the set that will indicate true belongs to sign. If it is a member of a set, then you put this sign. If it doesn't have the member, that is set does not belongs to. So these two are belongs to and not belongs to. You remember equal to and not equal to. Equal to means, always you write down like this, equal to sign everybody knows. But not equal to what? Like this, no? That is belongs to and not belongs to, does not belongs to. I will give an example. Set A. See, set A is having 3, 5, 7. First three prime numbers, isn't it? So set A is having this is the set A. Name of the set always will be in capital letter, remember. And set always will be between the braces or curly brackets. A set cannot be written other than any format other than between the curly brackets, and all the members inside it, members or elements should be there. Inside this, whatever it is called member or element, and it should be separated by comma. You must know these all are general aspects of set. So, see, 3 is a member of set A. 3 is a member of set A. Symbolically, we say it as 3 belongs to A. Similarly, 4 is not the member of set A, does not belong to set A. Children, sometimes some twisting question also will be there. 4 plus 3 plus 4. 3 plus 4 is how much? Summation is becoming 7. 7 is belongs to. But if you say 4 minus 3, it won't be, it does not belongs to. Do you understand what is called belongs to and not belongs to? What is called element, and how you symbolize an element is a part of that set by belongs to and not belongs to. Okay, now I will go to the second aspect, representation of set. How will you represent a set? Something has to be represented mathematically. No? How will you do it? So for that, usually we have 2 standard methods, but I will tell you 3 methods you should know. The methods are called description method, roster method, and scheduler method. See, tabular form is called roster form. Roster form has got 2 names, roster method or tabular method. Roster method can be said as tabular method. Don't get confused. Represent that one in tabular form. Don't get it confused that it, with scheduler method. It is a roster method. So tabular method and roster method both are same. You can say it as good name and nickname, or something of your own. To remember, scheduler method or rule method or scheduler. These 2 are standard form to represent a set. However, description method is also there. That means description method is what? You know, for any collection, if you use a very sweet phrases of English and put under a curly bracket, that also can be a set. I will take an example. See, even natural number. Even natural number, you know, 2, 4, 6, 8 and all. So even natural number, if you say within a curly bracket, that is called description form. It is an English phrase, no? It is not mandatory to form a sentence with the sparse of speech, with the proper formation of a sentence. No need. You write down in small expression of English. You write down within a curly bracket. That way a collection can be said as description form of a set. Now, see, a set, it was description form. The second form, you see, this one, if you put mathematical value, or if you express that one with some digit or some English letter or some words, then how will you do it? 2, 4, 6, 8. All the even natural number are 2, 4, 6, 8. Everybody know. So what will happen? 2, 4, 6, 8, and it goes on. That is why it is called infinite. This is called ellipsis. ellipsis. Ellipsis sign, that means after comma, don't forget to put comma after the last element, and then put 3 dot, and that order it follows. That order it follows to infinite. So that is called roster form, when you are putting the element within the curly bracket with a comma. But children, be aware, do not repeat an element. You cannot repeat element. You understand? So if 2 times 2 is there, only 1 time you have to write down. So 2, 4, 6, 8 is a roster form, and when you write down the third method to represent a set, which is called scheduler method is called as rule method, and rule method will be said with x such that x or any variable you take. A such that A also can be, y such that y also can be. There is no problem. But usually we take x as the variable, unknown variable in mathematics. That is why we will represent this one as x such that x, a small vertical bar or 2 dot. 2 dot is 2 like dot. 2 dot means column in English. So x such that x is equal to 2n. n belongs to natural number. Symbolically we have written in set builder method or rule method. This rule will be implemented here. So that is why it is called rule method. So what you write down? X such that X, usually a vertical bar or two column like symbol is equal to 2n. N is the natural number. You must know, a capital N means natural number before you go on set theory. Capital W means whole number. Capital Z or I means integer. Like this, some symbolical basic symbols you should know. These three you must know. Z or I. Okay, now see 2n, 2 into natural number, 2 into 1 is 2, 2 into next natural number is 2, so 2 into 2 is 4, next natural number is 3, 2 into 3 is 6, now next natural number is 4, 2 into 4 is 8, like this it goes on in that order. This is, otherwise you can write down very well this roster form of this particular roster form can be represented as set builder method. X such that X is an even natural number, X such that X, and then the description form you add it. That will be easy way. If you get confused the symbolically write down set builder method, then what will you do? X such that is X, then description form you use. You understand me? Now these are the three forms: description form, roster form, and set builder form. Now this is the representation of set. Now classification of set. Classification of set considering single set. Single set, if you consider classification of types of set, will be finite set, infinite set, empty set, singleton set. A set can be classified, if you are having a single set, you can classify it into this group: finite, infinite, empty, and singleton. So considering a set. Finite set is what? One example will be more clear. A is a set, X such that X is a prime number less than 13. This is set builder form of representation. So A is a set. A set is what? X such that X is a prime number less than 13. That means all the prime number less than 13 will be the set. Members will be what? The prime numbers less than 13 within the curly bracket. If you put it, that will be the roster form. A will be what? Within curly bracket 2, 3, 5, 7, 11. Could you understand? All the prime numbers are there. No composite number is included, and not after 13 or 13 is included, because less than 13 is set. This is roster form. Could you understand me? This type of, when the elements are limited, you can count the element. The members or the element, when it is countable, that type of set is called finite set. It has got a limit. The elements are limited. It is not unlimited or uncountable. That time it is called finite set. Could you understand me? Whether it's a set builder form, whether it's a roster method, that way. Now, infinite set will be when elements are not counted. If not able, means uncountable. It is limitless. Suppose you have got B, set B as all the natural numbers, C 1, 2, 3, 4, and then ellipses. That means infinite means all the natural number is infinite set, because natural number is limitless. Numerous natural numbers are there. Not numerous, infinite natural numbers are there. You can't count it. That is why it is called infinite set. When the element or member is infinite, means number of element or member is uncountable, infinite, that time it is called infinite set. Now, empty set is what? Basically, element won't be there. That is also called a set. Sir, what is the fun? That element is not there, and then also it can be called as a set. Yes, it is a set. George Cantor said. What? I will give an example. Suppose you have got a natural number between 1 and 2. Do you have a natural number between 1 and 2? No natural number is there between 1 and 2. No. After 1, next natural number is 2. Isn't it? So basically it doesn't have any element. How will you narrate this set? As C is the set, within curly bracket no element should be there, nothing should be written. Here even phi sign is written, that will not be empty set. Phi alone it will be either between the curly bracket empty space, or the symbolically this is called phi, means empty set symbol. This empty set can be said as null set, void set. Could you understand me? Now moving on to singleton set, having only single element. See the vowel in the word sun. vowel in the word sun. Description method I have used. Sun, only one vowel is there, U. Isn't it? A roster form D is equal to, within curly bracket, U. Isn't it? Element of the set usually is written in a small letter. Could you understand? Now, what do you understand by? Now, considering two or more sets can be classified into universal set, equivalent set, equal set. Universal set is what? Universal set means a set from where many sets can be created. All the sets is a part of that particular set is called universal set. Could you understand me? Take an example. Universal set will be symbolized as U or this sign. This sign I will write once. Children will be confused. Somewhere it is written. If you will have to write, you go this way, come this way, go up to this, and then do this. Could you understand? This is infinite. I mean universal sign, universal set sign. Or you can write down variable U. When you are doing Venn diagram, that time you have to put this sign, either this one or U. Now universal set all the natural number. Here see natural number up to 20 I have said to you. It will be the universal set. Could you understand me? Now natural number up to 20, because in the same order, after 6 I put comma, then ellipsis sign, then comma, again 20. Could you understand? Now universal set will have few sets with them. Universal set will have many number of sets, as see I have created one set as E, which is called 1, 3, 5. All the odd number is also a part of set. Now all the even number also will be part of the universal set. 1 to 3 will be part. Many sets can be created. From a set, many sets can be created, and all the sets member is the member of the universal set. The mother set, that set is called universal set. Could you understand me? Now I move on to equivalent set and equal set. These two concepts are very, very important. Equivalent set means number of elements should be same. Means cardinal number for two or more set, if they are equal, then they are called equivalent set. Cardinal number should be equal. Not exactly the members should be equal. I will give an example. Set M is 2, 4, 6. They are even number. First three even number I will written. Now set A is A, B, C. First three letters in English alphabet. See, here the cardinal number is 1, 2, 3. Here also the cardinal number is 1, 2, 3. Therefore, these two are equivalent set. This members and this member are not same, but number of members are same. That is why they are called equivalent set. Equivalent set is symbolized both the set name and then both the side arrow. This is a particular sign for equivalent set. Don't get confused. Now, equivalent set is what? P is a set when same number of set will be there. Cardinal number also will be same, and the element also will be same. Order may be different. Okay, now set P, A, E, I, O, U, all the 5 vowels. Now, if I say set Q is vowels in the word education. If you take the vowel in the word education, you will find again all the 5 vowels. So, these two sets are equal set. They are equivalent, fine, but equal set. All the equal sets are equivalent set, but all the equivalent set may not be equal set. Could you understand me? If the elements, the objects are of same ditto and number of objects are also equal, then they are called equal set. Now moving on to cardinal number aspect is what? Cardinal number, I say to you, as many member or object is there for a set is called cardinal number. How will you write down cardinal number? Suppose set P 1, 2, 3, 4, 5. You will count, and cardinal number will be written as capital N within bracket P. Then as many members are there number. No curly bracket to write down cardinal number. You will write down set name with the first bracket, not with the curly bracket. And N sign will be before that. N sign within bracket, first bracket, simple bracket, as many members are there, that is called cardinal number. So in this set, let me tell you, finite set cardinal number can be counted. For infinite set, cardinal number will also be infinite. So you don't have to. As it is a infinite set, you don't have to count the. You say infinite set. Cardinal number you don't have to write out. Now for empty set, cardinal number always will be 0. For an empty set, cardinal number will be 0 because no element is there inside. Okay. Now I will be talking about the subset, proper subset, subset or proper subset and superset. This This superset in Baiju they are telling us power set. Other day you are asking some of the student what is called power set, sir. Actually other name of superset. Could you understand me? What is called superset? From a set, as many set can be created. From a set, that particular set from the where you are creating many sets are called superset or power set. I will take an example and subset and proper subset. What is the concept? I will tell you also. See, set S I have taken where the elements are 1, 2, 3. 3 elements are there. First 3 natural numbers. Set S. Okay. Now this is called, the set S is called power set or superset. Now from here, how many subset you can create? Empty set always will be the first subset. Will be a subset of any set, and set itself also will be the subset of any set. You understand? Set itself and empty set will be always the subset, and all the junior set in it. See, 1 alone can be a set. Every member you take, 2 members combination you take. Then if you are having more than 3 elements, then 3 member combination you take. Like this you form. Here 1 can be a set along with 1. First empty set, then with 1 along the member, 2 along the member, 3 along the member, then 1 and 2 with 2 members set you create 1 and 2, 1 and 3, then 2 and 3 left with 2 members. Now the set itself, that's called subset. Subset means set itself will be included, and proper subset means excluding the set itself. Proper subset means junior one. Junior then the power set or superset is called proper subset. Could you understand it? Don't get confused. Now I will tell you the formula to find out how many number of subset you can create from a given set. If it is a finite set, n will be, n is the cardinal number. The subset formula 2 to the power n, n is the cardinal number. Suppose if this set, no, see this set n, 3, n, s means cardinal number, this set is 3. How many subset you can create? 2 to the power 3 means 2 to the power 3 means 2 into 2 into 2, that is 8. So 8 subset you can carry. But proper subset formula is 2 to the power n minus 1. Then 8 minus 1, because the set itself will not be there for proper subset. I hope you have understood. I will take from your exercise some of the sums and make the video and send to you.